All right, today we are jumping into this incredible story from the world of physics. And it's all about a really weird idea that sometimes the secret to a huge discovery isn't solving every single problem you see. Sometimes it's about knowing which problems to ignore.
You know, we have this image of science as a lone genius, having a eureka moment. But the truth? It's usually a lot more like this. It's messy. It's mechanical. It's a bunch of different ideas and different people grinding against each other, trying to get these giant gears of knowledge to turn, even just a little bit.
And that leads us to the core of our story. And it is a wild one. How on earth can ignoring a problem lead to a good theory? Sounds completely backwards, right? I mean, isn't science supposed to be all about solving problems? Well, as we're about to find out, sometimes the smartest thing you can do is stare a massive problem right in the face and just walk on by.
Okay, so let's set the scene. The year is 1981, springtime. We're at the Institute for Theoretical Physics in Santa Barbara. And it all kicks off with an idea that was beautiful, elegant, and deeply, deeply flawed.
So meet our two main players. On one hand, you've got Savas Dimopoulos. He's the guy who's just bursting with enthusiasm, with these huge, wild ideas. Then on the other hand, you've got Frank Wilczek, who's telling the story. He's the skeptic, the one trying to wrestle those wild ideas and see if they actually make any sense. It's that classic duo, the unstoppable force meeting the very much movable object who's willing to give it a shot.
So what was this idea Savas was so fired up about? It's called supersymmetry. And look, it is a gorgeous theory. The math is just so elegant. It suggests this really profound, hidden symmetry in the universe. There's just one tiny problem. Actually, it's a huge problem. The theory predicts a whole bunch of new particles that, well, we've never, ever seen.
And that right there is the giant, flashing red light problem. The theory is beautiful on paper, but as Frank Wilczek said, it's too good for this world. If it was true in a simple way, we should be seeing these superparticles all over the place in our experiments. But crickets. So what do? You have this perfect idea that just doesn't seem to fit in the real world.
We reach for a classic tool in the physicist's toolkit, something called spontaneous symmetry breaking. The basic idea is that the deep-down laws of physics could be perfectly symmetrical, but the world we actually live in isn't. Think about it like this. Take a chunk of iron. The physics governing it is the same in every direction. But once it becomes a magnet, it suddenly picks a north and a south pole. It breaks that perfect symmetry. And this was the hope for supersymmetry. So this idea sent our two physicists down a really long and frankly frustrating rabbit hole. Their goal wasn't even to prove the whole theory was right. They were just trying to build one single model that wasn't, obviously wrong. And the process was, to put it lightly, exhausting. You can just picture their daily routine, right? It fell into this crazy loop. Savas would come in, all excited with a new model. Frank would take a look, do the math, and find a killer flaw. Savas would go away, come back the next day with an even more complex model to fix that problem, and Frank would just find a new problem. And every time they went through this, the models just got more and more outrageously complicated.
Finally, after all this back and forth, they built a model that seemed to work. It had no obvious flaws. But not because it was simple or elegant. No, it was because the thing was so ridiculously complex that they, and anyone else who tried to analyze it, would just get tired and give up. It wasn't proven right, it was just too exhausting to be proven wrong. They had created a not wrong theory.
So there they were, with this monster of a model that they were almost embarrassed by. And that's when the story takes a sharp left turn. A little side project, something they did just to check something, was about to change absolutely everything.
Savas, ever the optimist, suggests, hey, why don't we try mixing supersymmetry with these other big theories about unification? And Frank was, let's just say, extremely skeptical. He was sure that adding all the problems of supersymmetry to these other models would just be a train wreck. He basically only agreed to do the math to prove to Savas what a bad idea it was. So, to quickly show how bad it would be, they did what they called the crudest thing possible. Just a quick and dirty calculation. And here, this is the absolute key to the whole story. They completely, totally ignored that giant, glaring problem they had spent months on. The whole question of how supersymmetry breaks and where the missing particles are, they just pretended it wasn't a problem. And the result? It was, in Wilczek's own word, amazing. You see, the standard models at the time predicted that the three main forces of nature would get really close to unifying at high energies, but they didn't quite line up. They missed. But when they ran their quick and dirty calculation with supersymmetry, bam, the lines met perfectly. It just worked.
And that was the moment everything changed. They basically threw that monstrous, not wrong model in the trash. Because this simple, straightforward calculation, which was technically wrong because it ignored the biggest problem, was so clean and so successful that it just felt right. It was a shift from not wrong to maybe right.
And this gets us to the really deep lesson here. It's not just about physics equations, it's about how science, and maybe discovery in general, actually works.
Looking back on it, Wilczek realized that progress doesn't always come from meticulously solving every single problem. Sometimes the big leap happens when you make a conscious choice to strategically ignore a problem that's got you stuck, so you can follow a trail that just seems more promising.
Now you have to realize how radical this is. We're often taught that science works because of people like Karl Popper, who said the goal is to try and disprove or falsify your theories. This idea of ignoring a known flaw to move forward, it's about 180 degrees in the opposite direction. It's about having faith in the beautiful parts of an idea, even if the other parts are a complete mess.
So that was 1981, a long time ago. What's happened since then? Is this beautiful, maybe right idea still holding up?
Well, here's the really cool part. As our measurements of the universe have gotten incredibly precise, the case for supersymmetry has only gotten stronger. Simply put, the models that include it just fit the data we have way, way better than the models that don't. That first crude calculation was really pointing them in the right direction.
But at the end of the day, math and predictions can only get you so far. You need to actually see the proof. And that ultimate test is happening as we speak, deep underground at the Large Hadron Collider at CERN.
And the stakes are just massive. If this whole idea of supersymmetry is for real, the crazy high energies at the LHC should finally, after all these decades, create those missing superparticles. If we find them, it's a monumental confirmation. If we don't, well, that sends a lot of people back to the drawing board.
So what can we take away from this whole saga? First, that progress is never a straight line. It's messy, it's weird, and it doubles back on itself. Second, putting an optimist and a skeptic in the same room can lead to incredible things. Third, and this is the big one, sometimes ignoring a problem is actually a brilliant strategic move. And finally, that beautiful ideas, even the ones with huge flaws, are worth chasing down.
And that leaves us with one final big question. Because this story isn't just about physics, is it? It's a lesson for all of us. It really makes you wonder, what are the giant, glaring problems in other areas, in technology, in medicine, and society, that we are all so focused on trying to solve head-on, when maybe, just maybe, the key to the next great breakthrough is to put that problem aside for a second and see what other beautiful ideas come into view.